Hello to all of you. This is Dr. Dhaval Maheta, and today we are going to discuss spot checking of regression algorithms. Spot checking is a way of discovering which algorithms perform well on your machine learning problem. It is not possible to know which algorithm are best suited to your problem beforehand. So this is the reason we have to do a lot of trial and error on number of methods and focus attention on well-performing algorithms. In this video, we are going to discuss 6 machine learning algorithms that can be used for spot checking the regression problem. Here, we will consider the libraries, that is, the scikit libraries used in Python. 4 linear machine algorithms are linear regression, ridge regression, lasso linear regression, elasticnet regression. Linear regression assumes that the input variables have a Gaussian distribution. It is also assumed that the input variables are relevant to the output variable and they are not highly correlated with each other. That is, we assume that there is no problem of multicollinearity. In case of ridge regression, it is an extension of linear regression where the loss function is modified to minimize the complexity of the model measured at the sum squared value of the coefficient values. It is also known as L2 norm. The full form of lasso regression is least absolute shrinkage and selection operator. It is a modification of linear regression, just like a ridge regression, where the loss function is modified to minimize the complexity of the model measured as a sum absolute value of the coefficient values. It is known as L1 norm. Elastic net regression is a combination of ridge and lasso. Basically, it combines the properties of both ridge regression and lasso regression. It seeks to minimize the complexity of the regression model, magnitude and number of regression coefficients by penalizing the model using both L2 norm and L1 norm. Now, let us see how we can do these regressions in Python. First of all, we will import pandas. From sklearn, import model underscore selection. From sklearn.linear underscore model, import linear regression. Then I'll specify the URL from where the housing data is to be fetched. Basically, I'm going to use the housing data. Then I'll specify the names of the variable: cream, zn, index, chess, nox, rm, age, dis, red, text, pt ratio, b, lstat, and mdv. My target variable is mdv. In case of regression, my dependent variable, also known as a target variable, is in continuous. It is continuous. Then I'll say data frame is equal to pandas.read underscore csv. URL. This is a URL from where the data has to be fetched. Delimit underscore white space is true. This data must be having the white space. If we indicate this as true, it will read this white space and segregate the variables. Names is equal to names. Array is equal to data frame dot values. X is equal to array colon comma 0 is to 30. Here X means we are considering the independent variables. Y is equal to array colon comma 13. That is a dependent variable. Seed is equal to 7. Kfold is equal to model underscore selection dot kfold into bracket and number of splits is equal to 10. Comma random underscore state is equal to seed. Now by specifying the seed, we are in the position to reproduce the results, same results every time. Shuffle is equal to true. Model which we will be using here is a linear regression. So we'll specify linear regression, round bracket, scoring. All these models require a basis for comparison. And here we are considering negative mean squared error. So scoring is equal to negative mean squared error. Results is equal to model underscore selection dot cross underscore validation underscore score. Model, this is a model which we are using. There is a linear regression. X is our independent variable which comes from here. Y is our target variable. Cross validation is to be done by k-fold. Scoring is equal to scoring, which will consider the negative mean squared error. Print the results, and we got the answer minus 23.734. We got the negative result because cross validation score function works on the maximization. We will take the absolute values for comparison. Now, let us run Ridge regression. We will run Ridge regression on the same data file. Import pandas. From sklearn import model underscore selection. From sklearn.linear underscore model import Ridge. We'll specify the same URL of the housing data. The names of the variables are specified. The data frame is specified as before. Array is equal to data frame dot values. Again, I'll specify x, that is the independent variables, y, the dependent variable. I'll set the seed. K-fold is kept same, that is a model underscore selection dot k-fold. Number of splits is 10. Random state is equal to seed. So 7 is considered here. Shuffle is true. Now here, the only change which will happen is case of model. Model is equal to reach. Scoring will remain same. And here, when we will insert the model, it will pick up the Ridge regression. Again, print the results, and we got the answer minus 23.88. So we'll compare the absolute values only. Then comes the lasso regression. Again, import pandas. From sklearn import model underscore selection. Basically, everything remains same till here. The only thing which change is model is equal to lasso. Scoring is equal to negative mean squared error. Again, everything remains same. The only thing which changes in the algorithm is model. Here we'll pick the lasso algorithm. Print round bracket results dot mean. So we got the answer minus 28.74. Now let us run the elasticnet regression. Everything remains same till here. The only thing which changes is the model. And model is equal to elasticnet. And again, we'll print the results. We got the answer minus 27.908. You can see the code. The codes are same. The only thing which is changing is model is equal to elasticnet. These are all linear algorithms. Now, let us pick up the non-linear algorithms. So, there are 4 non-linear machine algorithms. One of them is knearest neighbours. Second is classification and regression trees. Third is support vector machines. The k-nearest neighbors algorithm locates the k most similar instances in the training dataset for a new data instance. From the k neighbors, a mean or a median output variable is taken as a prediction. The Minkowski distance is used by default, which is a generalization of both the Euclidean distance and the Manhattan distance. If we talk about classification and regression tree, they are used the training dataset to select the best points to split the data in order to minimize a cost metric. Default cost metric for regression decision tree is a mean squared error, specified in the criterion parameter. Support vector machines were developed for binary classifications. The techniques has been extended for the prediction real valued problems called support vector regressions. This support vector machines can also be used for regression problems. Now, how we can do this? Let's see in Python. There is a small change which I want to do here. There are only 3 non-linear, not 4. KNN regression, import pandas. From sklearn, import model underscore selection. From sklearn.neighbours, import k neighbours regression. URL, same URL is specified. These are the names of the variables. Data frame remains the same. Array, x is the independent variable, y is a dependent variable. We specify the seed. K-fold, everything remains same. The only thing which changes is a model. Now here we will specify k neighbors regression. The scoring system remains the same and print results.mean. We got the answer minus 38.85. This is the non-linear algorithms we are using for this data set. Then comes the descending regression. Import pandas from sklearn, import model selection. Don't forget to import descending regressions. Make sure whatever model which you use, you will have to import its library. So neighbours regression, elasticnet, lasso. So you will have to make sure that you import its specific library. The model changes here. Model is a decision tree regression. Everything else remains same. And we again got the results minus 21.22. Next comes the support vector machines. So the thing which changes here is from sklearn.svm import svr. Everything else remains same. The only thing which changes here is a model is equal to svr round bracket. Print the results and we got the answer minus 67.64. Now when it comes of comparison, we have to pick up the value which is the lowest one. So you can see here the lowest one is generated by here 23.88, 23.74. So you can very well use the linear regression as it generates the lowest value. All these codes are given in the book Machine Learning Mastery with Python written by Jason Brownlee. For more videos on machine learning using Python, you can subscribe to my channel. You can see my playlist in which I have already uploaded many videos of machine learning using Python. Don't forget to press the like button. You can also follow me on LinkedIn and Twitter.